All right. It's not just the podium that's new. The other interesting news is that there's a new version of Unity out as of today. So 2019.1. So I've already done the upgrade. I want to tell you, it wasn't completely hiccup-free, and it probably won't be for you guys. So you guys should probably think of upgrading. It's not an urgent thing, but sooner or later. So I need to upgrade because I use it for a bunch of different things, right? So it's always possible to take an older project and import it into the newer one, whereas with the older Unity, you can't touch a newer project. It's a one-way street. So I need to be on the newer one, and what that means is eventually I'll push something out to you guys, and you'll be like, I can't open this if you're on the old version. Okay, it won't be today, though. Now I'm going to just show you, and also, therefore, get into the YouTube video here, the things that I ended up having to do, and I'm not sure what completely solved it. I'm still getting a bunch of warnings, which I don't like to see, but well, actually none are up right at the moment. But I was getting hard errors that were keeping my thing from running. So let me just show you what I ended up having to do. If you go into File and Build Settings, and then down here into Player Settings, there is a setting for that's kind of a global setting for how new the infrastructure, the programming language infrastructure, the C# infrastructure, and that includes the .NET environment, is that you're actually going to use for your project. So what I had here is it was on the older one. For some reason, it even says deprecated here, but that's what it had decided to use. So once I updated that, that seemed to help somewhat. Maybe that's enough to solve the problem. But the other thing I did, and you can always do this, just in case you get into a bind. So Unity is file happy. So the good thing about that is it's, a lot of the things it does take a bunch of computation time, and it's trying to cache that stuff away into files so it doesn't have to redo it again while you sit and wait for that to happen, right? We already know some things that are like that, like the baking of the lighting system, for example. You might have encountered that one where it wants to bake it and rebake it and rebake it. So we certainly don't want to discourage Unity from caching things to files, but there's a whole lot more files here than you actually need for the project. So if you get things into a weird state, one thing you can do is shut Unity down, come in here, and you can kill almost all this stuff. Almost all this stuff. Obviously not all, because you're going to lose your work then, right? The stuff you must keep are the assets and the project settings. Literally just those two directories. If you delete everything else out of here and then reopen the project, Unity will rebuild all that stuff. It takes a little time. And when it comes up, it won't remember what scene you're on, or you might have to click. There might be a little bit of clicking involved. But that's always possible. And this is also a good tip, too, because you'll notice that when I put something online for you, that's all I give you is those two. And therefore, if you guys, you might reach a point, right? You'll probably be using Unity beyond this quarter where you want to give a project to a buddy or send it to even a colleague outside NPS's walls. And if you just bundle up the whole directory, it's going to be way bigger than it needs to be. If you would just take those two subdirectories and send that out, you'll be much better served. Okay, so that's all I did.
Which two are those again, sir?
Okay, it is the assets,
okay.
Right? So you're always seeing assets coming up when you're in the actual tool.
Yes, sir.
Somewhere. Now it's hiding under the project settings and under my window here, but as soon as I get rid of that, oh yeah, here's my assets. So hopefully that helps make that stick in your mind. And then the project settings is the other thing. Those two are key. Everything else is optional. All right. Okay, so I'm going to now kind of jump back in where we were. If you remember, we had just, so I failed in what I really wanted to do last time, which was kind of a quick pass through everything, but I'm just going to pick up where I left off, and the plan is I will loop back to try to do a little more in-depth. Oh, and now the audio is working? Oh, they're spoiling us. All right. So you remember this thing, right? So there's a crosshair in the middle. You click around, and it figures out what you're looking at, and it puts the little red sphere there, all right? So this clearly has a lot to do with the basic functionality that I may be asking you to demonstrate already next week, but the whole idea is build some kind of a game. What's the easy game to build given what we've shown you? It's a first-person shooter game. So here we are. We're in first person. We have a crosshair where you can see where the bullet impact point is. There's a lot of goodness here to be gotten out for you guys to make your life easier with the project, especially if you want it to be easier. Okay? All right, so let's, hitting escape and stopping the thing, let's go over and look at the code and see a little bit of how the sausage is made. Let me see, I don't have my asset. I can't edit the script assets yet until I get Visual Studio up, so I'll do that. All right, and you can always just find stuff over here, or you can, if you want to work the other way, which maybe is advisable, you come over here, you come over to your script, and you say, I want to edit it, and it will pop right back into that window, but with the correct script out. Okay, so here it is, the camera ray script. Camera ray script. So it is actually not attached to the camera. So you see it's got a couple of public fields there, right? A public camera and a public game object, which is the impact marker. Okay? Now if you look over here, you see on the script, oh yeah, right? So this should, at this point, hopefully this is starting to sink in. This is normal. If you say something's public, the inspector makes a slot, and then you can assign to it in the inspector. This is the normal path that you use to let one game object get a handle on another game object. Okay, again, there are other ways to do it. I also showed how you can find it by name. That's fine. What if you have two things with similar names or the exact same name? I mean, is that possible? It might be. I mean, I don't know. Here you can drag a specific one in, so this is certainly something you need to know about. And you can see I've already dragged the camera into the camera slot, and the impact marker, what could that be? Oh yeah, it's the red sphere, of course. Okay? All right, so that's that part of it. And then I have a viewport center field here. Okay, viewport coordinates go from lower left, 0, 0, to upper right, 1, 1. Apparently it's just using X and Y for those viewpoint coordinates and not Z, right? Because again, the viewport, the idea is that's basically like your physical window. So there isn't any depth to the plane of the window, so we don't need Z. Okay, not even sure why we're putting it in a vector 3 then. We could put it in a vector 2, but hey, I just work here, so. What else is going on? Okay, in the update, what do we see here? Input, get mouse button down with an argument of 0. Okay, so input we have seen before, right? We saw a similar thing. I think it was just called get key press, maybe. It's there in the code. That's why I'm giving you example codes. So I can't keep the call straight in my mind either. Okay, but it's a very similar pattern. It is a polled system where if we want to know that the mouse button is pressed, we need to ask when our script is updated. Okay, mouse button 0 is just the left mouse button. I think then 1 is the right mouse and 2 is the middle mouse, I think. Okay, but that, again, that's why we have documentation. That level is probably easily documented. All right, so when the user clicks, right, that's a shot is supposed to happen, right? So you will notice that the code to deal with the shot is pleasantly short. So if you want to do something very simple and default like I'm showing you, it's not hard at all. Okay, there is a raycast hit type object there. Okay, raycast, what's that? Okay, literally just casting a ray out, right? That's anytime you want to draw a line in a simulation because you want to know what that line intersects, right? We call that raycasting. Okay, that is again an expensive operation, and a lot of code and effort goes into all simulation and game platforms to try to make it as efficient as possible. But don't go. But beware. Unlike some other aspects of the simulation where you can just kind of put, it seems like you can scale things up indefinitely. You will find you can't scale up ray testing indefinitely. Every year it gets better, So don't assume prematurely that, oh my gosh, I can't do more than one raycast because the professor's example only did one in an update. No, you can do way more than one, but not an indefinite number. All right. Okay, so the hit is actually supposed to, we're going to use that for feedback. That's what's actually going to tell us what got hit, or maybe that nothing got hit. Okay, and then we have this. This is the key call that sets up the ray for us. Now, setting up a ray could be as elaborate as you want to be. All gamer simulation systems use ray casting, and so they typically will let you set up a ray in a flexible way. Okay. Now, if you think about it, what's a ray? I mean, we need a point of origin and we need a direction. Okay, that would be the minimum. Okay. But here we see, where's the point of origin? Where's the direction? Here. That's the beauty of this. They've got a nice convenience method there that's attached to the camera that basically just automatically constructs the ray given the camera's viewpoint. Okay, and we're saying we want to go through the center of the viewpoint, so there we have it. Okay, you'll see a little different twist on this in the next example, but that's really handy. Okay, now what you could expect is probably there are a lot of other alternatives, right? Certainly one where you say, here's the origin, here's the ray, and if you're going to go that far, then maybe say, test the ray, maybe starting at this distance and only go out to yay distance. I only care about things that are in that kind of a window. Those would be the kinds of things that are typically supported in the API for raycasting for a game or simulation. Okay, now what exactly is here in Unity? Well, got to take a look. It just updated. Stuff could have changed. Okay? Good. Other ways of specifying rays, you might see methods where you have the origin point and then you say trace the line segment out to this other point. Okay? No direction because it's implied by the 2 points. No ranges because you assume that this is the starting point, that's the end point. You want everything that could get intersected along the way. Okay? There are usually ways of getting everything from just the first object, which is what I want now. Okay, so again, this is a simple model of bullet physics. So you hit the first thing and the bullet stops. Okay, now in the real world, it's not that simple. Okay, but that's the simplest possible model. So I just need the first thing that gets hit. But there are usually methods that would let you go to the second, third, fourth thing, and I'm sure Unity has those as well. All right. So now we set up our ray. Again, what's the ray? It's just the direction. There's been no ray cast yet. We're just going to use the ray as a tool to say, okay, now do this expensive, Unity, go do this expensive operation and see what intersects that line. Okay, that is done by physics.raycast. Okay, you give it the ray, the specification. You tell it that you want a hit back. So there's this out keyword. Now that's not a new thing. I don't know, is there a Java equivalent for that these days? Yeah, that was kind of weird to me with C#, but it's a handy thing. So that's a variable there where you're saying that's just going to be something that you're going to use to communicate back to me. This gives you another path. If there are many things that need to come back, you could have a bunch of out parameters here. That's pretty handy. Okay, that's what that thing is about. Okay. Now I'm passing in. You have to give it the object, right? So it's right here. I have to give it the object, but you see I didn't initialize it. And the out parameter there tells Unity that's okay. It's okay that it's not initialized because it's supposed to be something that is initialized inside the function and returned. Okay, so then what do we do here? Once we know, so hit actually contains the information. So it's probably got a lot more in it. So this is why I want to do another pass. We should maybe open that up in the manual. It may have all kinds of cool stuff in it regarding that ray trace that happened. Okay? But I just want the simplest possible thing. And if you just do hit.point, that gives you the 3D point in space where the first impact happened. Perfect for the simplest possible shooting model. Okay? And then I'm just going to my red ball impact marker, right? That's my game object that was loaded in the, I got bound to the red ball in the inspector. Get used to this. It takes a little getting used to. This is the normal way to get a component on the object, right? So what do I want to do to the red ball? I want to move it. Well, the red ball doesn't even know where it is. It's a component on the red ball that tracks its position, the transform component. So it's not enough to have the red ball. I've got to get the transform component. From here to here, that's the normal incantation. Now make it your friend. Okay? From the transform, I don't care about the whole transform. The whole transform will have stuff like scale in it. It will have stuff like orientation in it. I don't need all of that. I just want the position. So dot position and assign it to the hit point. And what does it do? Exactly what you saw. The red ball will pop in that frame to the impact point. Any questions so far? Again, we should double back, but yeah.
Out hit part again.
Yes. So out as a keyword just means that this parameter is not information getting passed into the function. It's strictly stuff that's coming back out of the function.
Okay.
Okay? So it's getting assigned, blump, 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 blump. Where does it actually get assigned?
Hit dot point.
Well, when this thing actually runs, at this point, it's now assigned. And then what do we have to do to actually, well, hang on, what's going on here? Okay, it's obviously, it's getting assigned in a function that's not up here. Okay, sorry, I'm getting confused. It's getting assigned in physics.raycast. We don't have that code, right?
Okay.
All right.
But that same word physically hit in the game space.
Yes, among other things. You should be curious about that in the back of your mind. What other goodies could be there in the hit structure?
Very curious.
Okay, good. Stay hungry. All right. Now let's go to the fifth and last example to demonstrate some other good stuff. Okay, so when I play here, you see it's raining cubes. All right, and what you can do with this one is if you click on a cube, look, they're alive. Okay. All right. In fact, you can have fun if you click multiple times. You can have a levitating cube. If you've got way better dexterity than me, maybe you could keep multiple cubes up in the air. I sure can't. All right. So what's going on? Clearly, a physicsy example. Lots of scripting goodness in there. Let's see if we can, let's get make our first pass and get the most of the juice out. Okay. So let's go. You see, I have a mouse ray script holder over here with my mouse ray script. Okay. Now you see over here. What does the script have as public objects before we even open it? Here's the camera. It needs to know the camera. Here's the force that is actually getting applied. Now, a little hint. Do you remember the difference between forces and impulses from fall?
Impulses take or apply within 0 seconds.
Yes. An impulse changes the velocity of an object instantly. Okay, it's a direct momentum transfer to the object. Whereas actual physical forces, it doesn't matter if it's the force of a nuclear bomb blowing off, it does nothing in 0 time. It requires time to actually affect the world. Okay? They are both abstractions. Forces are abstractions, and impulses are abstractions. It just happens that forces are the ones that are always taught in school, and that's the one that probably, for a lot of engineering applications, is perhaps arguably the most useful, okay? But impulse is another way to cut it. For forces that act very quickly, like an explosion or a blast, it's a very good model. Okay. This is an impulse, and I'll show you that. It's a little ugly, I would say, how Unity's arranged it, but certainly still slick from a programming point of view. Slick and easy, as we would expect from Unity. Okay. So, right now you can sit and play with this thing. Actually, you can even do it with it on. Now, remember what happens. What happens when I adjust this thing when this is on? What's the red light that I should have?
Doesn't save it.
It's not going to save it. It's fine for messing around. Once you back out, the changes are typically gone, with rare exceptions. Okay, so like I can go in here and add like a lateral component, an X component to my force. All right, let's add in a 1. Okay, now look. I don't know if I get 1 to hop on top of the other. Damn it. Okay. All right. You get the idea. Okay? Pretty handy. That. Let's go and say we want to edit the script. Okay.
I have a question. It's
Yes.
probably a dumb question. But
Well, that's all right.
what is the script holder? Like, what type of object is
It's
that?
an empty. That's a great question. Yes, it is an empty. You will notice when you go into create. Let me show you this because we do it all the time. So you know the saying, if you've got a hammer, everything's a nail. Okay, so they've got a game object, which is a great idea for organizing 3D scenes, okay, except it actually doesn't fit with literally everything. But they make it fit literally everything, right? So if you've got something and I'm like, well, I just want to put code on it. It doesn't appear in the scene. There's no geometry. There's no materials. They still make it a game object, so that's the notion of an empty game object. Sometimes you'll use it just to say where a position is. You don't actually want a physical object there, but you want something that has a position. Empties actually do have a position too. So look at this guy over here. Yeah, here's my script holder. Yeah, he's got a position. He's at X of 17.8 meters. Okay. If you double click on him, it will show you. There he is, floating in the sky. Actually, it might look like it's the cube. It's not the cube. Let me do this. It should not be the cube. Is it the cube? Is it right on top of the cube? It may be right on top of the cube. Okay, but it doesn't have to be. It's not the cube. See? There you go. It's got its own position. What does that mean? It's just a code holder. It means nothing. Okay? The way you create it is you can just go and, right-click and create empty. There you go, right there. Okay? All right, so now let's actually look at this code. Looks similar to the other one. We see our camera. We got our force there, the public object. We're setting up a raycast hit again because we're going to shoot a ray. We want to know what happens. Okay, we're looking for mouse button 0 going down, same as before. But now notice that the specifics of how we set up the ray are different. And again, gotta love this. This is something that this is where you really get some mileage out of having a relatively large system like Unity, which has put a lot of effort into trying to make things easy. Yet another nice convenience method to use to set up your ray. You go to your camera, screen point to ray, okay, and you literally just take the mouse position that you get from the input, okay, it just says wherever the mouse is, and it will construct a ray that gets shot from that point on the screen, right? Not from the center like when we were shooting, but from wherever the mouse is, wherever that cursor is, it shoots from there directly into the scene and sees what's underneath there. This is really good for editing objects. This is good for hooking objects. If you want to be able to command, you want to have a little gopher, wingman coming along with you through your simulation. You want to occasionally click on him and give him some instructions via key presses. This is a great way to be able to hook him, right? Click and get a hold of him. Well, if there's just one, it wouldn't maybe be so important to select them, but let's say there's two. Right? Which one do you want? Okay, we then shoot the ray. Now, look at this. If the hit has a rigid body component, that's what this is about. Hit.rigidBody will only be non-null if the object that you clicked has a rigid body associated with it. Why are we doing this? Well, we don't want to be clicking the ground and having weird stuff happen, like our program crashing or something like that. Okay? And rigid body is typically the way you have a rigid body component for most physics objects that are going to move around. You don't want them to go through other objects. They're going to bounce off other objects. You want to be able to apply forces to them. The way you do that is adding in a rigid body component. And I've seen those in the tutorials, and you'll see them in the scene as well. Okay, and then over here is how you actually add a force to a rigid body. Hit.rigidBody, add force. Here's the force, but notice this additional optional parameter, force mode, velocity change, that makes it an impulse. So it's treating that not as a force, despite force, add force mode, it's not a force, it's an impulse. Okay? That's the way you get an impulse.
So for example, could we take this script, add it to the last example we're looking at with the camera ray,
okay,
and essentially add it to where, like, if I'm clicking and the ball gets transported there, but if I'm just so happen to be clicking on a rigid body, would that rigid body thusly shoot away?
You could make it by adding a force in the appropriate direction.
Okay.
Right? So you'd be maybe looking, you want to go, again, should make you more curious about the rays. Well, I need the ray as a vector, because I want to shoot it in that direction, the direction of the ray. Where's the ray as a vector? Probably in there. We should see. All right, but I'm going to loop back around in the beginning. Okay, so that constitutes one quick pass through. That should give you a good idea what kind of stuff I'm going to be asking you. I'll make an assignment pretty soon and put it out there so you can see what I'm really going to ask you. But it's going to be a list of 5-6 things in your little application for the week. Show me these things. All right, so let's go back to, I don't say. Okay, let's go back to callbacks and object access. Let's see if there's any more to be gotten out of the example here. Let me remember what this is. All right, okay, so maybe not this one. This one might have been pretty cut and dry, but let's take a look. So you remember, this is the thing that where we just show how you can grab a hold of other objects, and it also demonstrates that, stuff like, awake happens before start. An update happens a lot of times. Remember to look where you care about how many times a message got triggered. Remember to look far to the right to see how many times that message got triggered. In our case, 5 times for in update. Okay, this one seems kind of boring. I will open up the code anyway, just because. Let's just see. Yeah, there might be something to play with here. Let me see. Transform position. Yeah, my transform position. Right, so like using this to get my transform. I tried this the other day. Right, I think we went in here and we just put lowercase transform down here. Okay, that is one of the convenience accessors that they have in Unity. So remember that. So if you're in a component and you want to grab your specific game object, the one that owns you, right? You can just do lowercase g, uppercase O, game object, and that will just grab that. You don't have to do anything fancy. You don't have to find it by name. You don't have to do anything. Likewise, the transform, because that's so commonly grabbed, if I were just to make this a lowercase t transform right here, okay, we did that last time. You can try that and verify that, yeah, that works just fine. So this whole, look what you have, this is what you have to do otherwise. Okay, that's kind of a complicated incantation. Now, for the other object here, the cube, let's play with that one. I wonder if I can just do cube dot transform like this. What the? Fingers get off the home key there. Still not right. Still not right. Okay, eventually we'll get there. Cube is not.
Would it be M underscore cube?
M underscore cube. Thank you. All right. Let's see if that works. It looks like it. Looks like it did. Let's just, before I start it, let's check the old reported position of the cube. So it's that 2, right? It's reporting the x position is where I'm using this. No, it's complaining about something, but I think it might still be all right. Let's see. Okay, again, the console typically clears. Yeah, it's working fine. Okay, so that works even for the other object. Okay, but still. So you might think, I don't have to worry about get component transform at all. Yeah, that's right. You don't have to worry about get component transform. But what about all the other components? You got to use this. That's why it's here. So learn the incantation, like it or not. It's ugly, but learn to love it. The object, game object dot get component, angled braces with the type of the component, and it's a function on top of it, so you need rounded braces outside, parentheses. All that's got to be there or it's not going to work. All right, next. Let's see what other goodness we can get out of this guy. Input and instantiation. Again, what was this? This is the one where we're just spawning a bunch of cubes, right? All right, so I think there's some stuff we could play with this one. So let's take a look. The code is in the plane. Spawn cube script is attached to the plane. All right. Yeah, I'm curious. could we actually, how hard would it be to make the object be born with a particular velocity? Maybe this will be a fail, but. So my cube prefab, first let's take a look at that. I don't know that we opened it up. It used to be you couldn't even open these prefabs up. They were kind of like little black boxes. But so this is my, this guy, physics cube is my box. You will see that it has a rigid body component with it there. Okay. And let's see. Let's see if we can set initial velocity. Let's see what Google recommends. Unity, set initial velocity of rigid body. Let's see if we get any good. Yeah, look at that. This has got a velocity field. Good. Let's see if we can use it. Okay, this is good practice. Okay, so we initiate the cube prefab. I wonder if instantiate. I would guess it's going to return the actual object. So I would guess that we're going to get the game object back here. Maybe I'm all wet. Okay. New cube equals. Let's see. Yeah, looks like I might be. Oh, it's a transform. Okay. So here's the thing. Again, remember, transform is kind of a more is often used to refer to a game object. It's a little bit weird because transform is not literally a parent of the game object. Transform is a component, but that is often done. I don't really understand that. Quite often, where I would have put in a game object, I see people who do more with Unity than I do will say it's a transform, and it does allow you to assign a game object in there. So, assignment for you guys: why is that? What's going on there? Okay, but it is a thing. So I could either make this a transform over here, but I'm going to leave it as a game object. How can I fix it? This returns a transform. I want a game object. How can I fix it? No, you can just coerce it. It's easier than that. Yeah, it's type coercion, right? This should be something you have seen, right? We can force it to become a game object. I'm not even sure. I think we can anyway. Well, maybe not. Cast is redundant. Wow.
Well, so you can just assign it to
dot
new
game
cube.
object at the end.
What's that?
Dot game object at the end of instantiate. That means after the brackets, after you invoke the function, you just put dot game object.
What do you mean, like over here?
Yep.
Dot game object?
Yep.
Oh, I see what you mean. Lowercase game object, the convenience accessor. Okay, maybe. Or not. Interesting. Why is that? That is so strange. So first it says I got to coerce it, and then it says no luck. Okay, well, it is a transform, so let's try this. What is it? Now what don't you like? Stated statement cannot be declaration. All right, let's take a look at the documentation for instantiate. I think there's something interesting going on there. Instantiate. All right, object.instantiate. Instantiate object original. It says public static. Oh, it's returning an object. Yeah, but that should still coerce to a game object, I would think. Interesting. Well, let's see. Let's see if we can get some good advice here. Transform. Well, transform is what I did. Oh, look at this. As transform on the far end. So why not as game object?
You put game object in brackets not with a dot for instantiate. Is the difference?
Yeah, no, I don't think we. You're looking at this one up here?
Yeah.
Yeah, I don't think that's actually needed. Yeah, all right. Well, let's try this exact. Let's try this exact incantation, which I feel confident is going to work, and then we'll see if we can't shorten it down a bit. Let's put our notes over here. All right. As transform, right? Still not happy? Well, we can put the. I don't think the game object instantiate can be anything other than normal instantiate. Name can be simplified. Let's see what fixes they have in mind. See, dropping the game object is what they recommend, but that doesn't solve the problem. All right, this is surprisingly obscure. Here they're making no recommendation. Okay. Well, anyone have any ideas?
Could it be something with hard typing new cube as a transform?
So, well, we can say var and let it decide what it is. Still doesn't like it.
Just a random shot.
It seems to know it's a transform. If we get rid of that, then it'll just be an object, I'm pretty sure. It still doesn't like it. What happened to my return? My returned object I was promised. Gotta be a way to grab it. Well, there's going to be homework for me because this is just unbelievably obtuse here. Object the instantiated. All right. Well, let's see if we can figure that out. Okay, but we won't deal with that right now. Let's leave this alone and not going to save it. Let's close it. Maybe we can get save changes. No. All right. Let's go on to the next one. See if we can. Have to leave that for another time. Sorry about that. All right. So let's see if there's anything good here. Okay. Again on the plane. Oh, it's the same spawn cube script. Right. So you guys remember this one? This is the one where the cubes fall just like before. But if they hit the red thing, they get deleted. Okay. The main point about the red thing is that it's set to be a trigger. So it's in its collider. You see that is trigger is checked. Okay, and then there is a script there, which I think we looked at last time. Yes, we looked at this. It's very, very simple. Yeah. Okay, if something enters, it gets destroyed. All right, that's pretty cut and dried. I'm going to consider that one's in good shape. All right, let's go on to 4. Okay, so our shooting example. So this is an important one for us. Let's take a look. Okay, so the first thing to talk about here is the crosshair. Okay, so the crosshair, you see, is there's a canvas, and if you open the canvas widget, you see it's got an image on it, and that image is the little dot that you're seeing on the screen. Okay, so I believe I just pulled that in because it happened. I think that dot was actually there in Unity, but I'm not 100% sure. In general, what you do is you go looking on the web. If you want something that looks realistic, that looks like an actual crosshair, you can go on the web and get it. You certainly can create one yourself inside of GIMP, right? And then when you place it, notice that it's set up so you will see, so for a canvas, when you put an image on the canvas, you will see that has controls that let you say how it's supposed to be positioned, right? So we want it to be centered. I think if you click here, see there's all kinds of other modes here, where we're asking it to be centered on the, with respect to up and down. We want it to be centered with respect to right and left, and that's this option right here. Okay, I think you can also have an offset. If you put an offset in here, I would expect that it's going to go and move around. So there you go. Okay, so you have a lot of ways to control it. Okay, and then the canvas. So one thing about the canvas is the way they typically are used is that they're just showing up in front of the camera. So that little dot will kind of always be there. You'll notice, actually, even in this, if I go way back out, where is the actual camera? Well, the camera is the one that's on our FPS controller. The FPS controller is down here. So you'll notice they don't actually put the camera and position it with respect to the object. So that's a little bit of magic going on. It's different than anything else that you do in Unity, but that's for a good cause.
So it's kind of like on Survival Shooter, where when we put in like the game over and everything, it draws us out to like this giant scene deal, and that's where you're like placing everything. Like so
that was a canvas there, no doubt. Yeah. Right. Okay. And even though it physically exists in the space, it's misleading where it is because it's always going to show up in front of the camera. Okay. Just one of those things. Okay, what other stuff is here? I mean, that might be worth doing tomorrow, just to kind of go through those steps to make sure you're solid on that. How you create that stuff. What other stuff do I want to talk about here? Let's look at the script again. Let's see if there's any goodness I can get out of here. We could do some stuff. You can maybe mess with the mouse button, though the left mouse button is almost always better than the other choices. I think one's going to be the right mouse, but we can check that experimentally here. All right, there you go. It's the right mouse now, so 1 is the right mouse. I had that guess was right. 3 is no doubt the center mouse. Compile. All right. Now, hopefully you do know what's center mouse. Oh, no, it's not. Interesting. Oh, it should be 2, yeah. 0, 1, 2. 0, 1, 2, not 0, 1, 3. Yep. Yeah, it does get me after a lifetime of doing this. Now you guys notice, yeah, there you go. Boom, okay, that's fine. Every time you come back into the screen when you've altered a script, you guys know to look for the little symbol down in the lower right. That shows you that things are compiling. Okay, that should be something that you look for. Otherwise, it can be frustrating. You come back and you try to do something else with the interface, and you'll notice it doesn't work. Why? Because it's busy and it's compiling the script. Okay, so the first thing when you come back here is you just look for the little symbol. Just be patient, wait for it to go away. If you've got a lot of code, it can take a little bit. But usually it's good at doing incremental compilation. If you just change one file, it's probably gonna be really, really fast. What other stuff? Git component. Okay, so that's pretty good. Let's look at the last one. Don't save anything. Let's look at the code. Okay. Screen point array, using the mouse position. What might be interesting to mess with here? Okay, so one thing we could do is we could try taking out this velocity change, but then it's going to be Okay, let's take a look. Tell you what, let's take a look at the input object. Okay, Unity manual or API input. Okay, so the mouse press thing, you're looking for a click, right? If you don't want to click, there's another way to do it. Get mouse up. Okay, so there's get mouse button, which will just return whether the mouse button is held down. Okay? If we want to apply actual forces that take time, we probably should be looking for the mouse button being held down, right? Because we need to have it be held down for multiple frames. Okay, so let's just try get mouse button up here, and then we'll try backing out this. I think we can just eliminate this entirely, this velocity change. I think the default is what we want. So if we go in now, let's see if we get any errors. Doesn't look like it, so it's giving me some yellow warnings. I don't like it, but I'll live with it. All right, now if we go over here, it doesn't seem to be working. Oh my gosh, okay, it was just that the force was low. Okay, so even 300 is not crazy high. All right, so let's go back, let's back off to 30. Okay, so now you should see, okay, well, let's go back where we were. Let's go back to 3 and just be really patient. Yeah, I'm clicking on this cube. I'm very patient. Very, very patient. Come on, guys. Maybe it's getting overwhelmed by gravity is what's happening here. That the net force with a force of 3 up is just, right, so probably needs to be, yeah, maybe at least 10. If that's unit mass, but it probably is. Oh, there we go. Blast off. All right. Okay. So I think we'll leave it there today, guys. How we grab objects when they're born from instantiate, that's weird that that's not working. I'm interested in that. Let's see if we can figure that out. You might want to mess with that. Other stuff we should look into. So we should maybe play around with the canvas a little bit just to make sure you've done enough on your own. That's no big deal because that's absolutely something you're going to need to do in the future. All right, think about it. If there's anything else we should do, we always try to do it on the fly. If I know in advance, I can maybe be a little more assured that things will actually work out instead of learning by painful experience like this morning with the instantiate. Okay?